Hello everyone, and welcome to English Speaking Gym. I am really happy you are here with me today. Today we are going to train our English while learning something interesting about everyday science. Our topic today is how soap cleans better than water. Put on your headphones. Relax your shoulders. Take a slow breath. And let's begin shadowing together. I wash my hands many times every day. Before eating, after touching something dirty, after coming home from outside. Most of the time I use soap. But have you ever wondered why soap works so much better than water alone? At first, it may seem like water should be enough. Water can rinse things away. Water can remove some dirt. But water alone cannot remove many types of dirt and grease. This is where soap becomes very important. To understand this, I first need to think about what dirt actually is. Dirt can be many different things. It can be dust from the air. It can be oil from our skin. It can be food grease. It can even include bacteria and viruses. Many of these substances contain oils and fats. And here is the key point. Oil and water do not mix well together. You may have noticed this in the kitchen. If I pour oil into a glass of water, the oil does not dissolve. Instead, it floats on the surface or forms little drops. This happens because water molecules and oil molecules behave differently. Water molecules are attracted to each other. Oil molecules are also attracted to each other. But oil and water do not easily combine. Because of this, when I wash my hands with only water, oily dirt sticks to my skin. The water flows over it but does not remove it very well. The grease remains attached. This is why soap is necessary. Soap has a very special structure. Each soap molecule has two different ends. One end loves water. Scientists call this end hydrophilic. Hydrophilic means water-loving. The other end avoids water but loves oil and grease. Scientists call this end hydrophobic. Hydrophobic means water-fearing. This special design allows soap to connect water and oil together. When I rub soap on my hands, the hydrophobic ends attach to the oily dirt. At the same time, the hydrophilic ends remain attracted to the water. As I continue washing, soap molecules surround the dirt particles. They form tiny structures called micelles. Inside a micelle, the oily dirt becomes trapped in the center. The soap molecules hold the dirt inside like a small cage. The outer part of the micelle interacts with water. Because of this, the dirt can now move freely in the water. When I rinse my hands, the water carries these micelles away. In other words, the soap lifts the dirt off my skin and allows the water to wash it away. Soap also helps reduce something called surface tension. Surface tension is the force that holds water molecules tightly together at the surface. Because of surface tension, water sometimes forms droplets instead of spreading out. Soap weakens this tension. As a result, water spreads more easily across surfaces. This helps the water reach tiny spaces and remove more dirt. Another important benefit of soap is how it helps remove germs. Many viruses and bacteria have protective outer layers made from fats. Soap molecules can break apart these fatty layers.
It keeps our homes clean. And it works because of a clever molecular design. Let me explain the main idea again in a simple way. Water alone cannot remove oily dirt very well. Oil and water do not mix. Soap molecules have two special ends. One end attaches to oil, the other end attaches to water. Soap surrounds dirt and forms micelles. These micelles allow water to carry the dirt away. That is why soap cleans much better than water alone. Understanding this process helps me appreciate something I use every day. A small bar of soap may seem ordinary, but inside it, millions of tiny molecules are doing complex work. They connect oil and water. They trap dirt. And they help keep us healthy. Great shadowing so far. Now let's practice some important vocabulary. I will say each word slowly. I will explain the meaning. Then I will give an example sentence. Please repeat each word with me. Molecule. A very small particle made of atoms. Example. Soap molecules attach to oil and water. Hydrophilic. A substance that is attracted to water. Example. The hydrophilic end of soap connects with water. Hydrophobic. A substance that avoids water and prefers oil. Example. The hydrophobic end of soap attaches to grease. Micelle. A tiny structure formed when soap surrounds dirt or oil. Example. Soap forms micelles that trap oily dirt. Surface tension. The force that makes water molecules stick together. Example. Soap reduces surface tension so water spreads more easily. Bacteria. Very small living organisms that can sometimes cause disease. Example. Washing with soap helps remove bacteria from our hands. Now let's practice some useful power phrases.
This is where the real problem starts. Example. This is where the real problem starts, when things do not connect properly. This is what makes it work. Example. This is what makes it work when everything comes together. This is what makes it work in real situations. On its own, this is not enough. Example. On its own, this is not enough to get the result. On its own, this is not enough. We need something more. This acts as a bridge between the two. Example. This acts as a bridge between the two systems. This acts as a bridge between the problem and the solution. This allows everything to come together. Example. This allows everything to come together in a simple way. This allows everything to come together and work smoothly.
Excellent work. That brings us to the end of today's lesson at English Speaking Gym. I hope you now understand how soap cleans better than water. And I hope your pronunciation and listening skills are getting stronger. You did a fantastic job shadowing with me today. Remember to practice English every day. Small daily effort leads to big improvement over time. Come back again tomorrow for another exciting topic. I will be waiting for you. Thank you. Stay strong, and see you soon.